And but hopefully these tips and guidances should be the ACM banquet at the end of the year, where we have like stoles and stuff. Okay, so this is for technical interview prep, and technical interviews are usually a lot different than just like a regular interview that you might have for a job, right? In technical interviews, you are going to be asked to solve usually some kind of like leak code problem, some sort of programming problem that tests your skill to make sure that you know how to program, right? You know how to use a loop, you know how to use conditionals. So for example, a question might be, if you're given some array of integers, can you find all numbers that are duplicated, right? That have multiple occurrences in the list. So you'll need to work through that and talk aloud as you solve the problem. And so this advice is geared towards that type, right? Technical interviews. So to get started with problem solving, you are going to want to take a look at a list, a collection of problems that show up a lot, that teach you common patterns and themes, so that you can really focus your practice instead of just trying any problem, and the problems you try might be too hard, might be too easy. These lists that I'll go over are a really solid collection of problems that if you can only solve 75 or you can only solve so many, right, you want to solve questions off of these lists. And the lists in question are the LeetCode 75, which is available on LeetCode. If you go to, I think, the problems tab, and then there's like a study section, it's called study something, should be simple enough to find. The LeetCode 75, and then this is the NeetCode 150, which is a superset of the LeetCode 75. You can find this on, I believe, neetcode.io, I think, is the domain. So that includes all the problems from the 75 and includes some more. And you can see here the different topics that will be covered, starting with arrays and hashing and going down all the way to something like dynamic programming. And the way I would advise solving these is doing the easies first, so you kind of get a grasp on the different techniques that you'll be using, and then move on to the mediums, right? And then the hards if there are any. Because you don't really want to go on like one. You want to basically cover as many techniques as possible first, and then do a deep dive, right? If you're doing dynamic programming, you don't want to like go from easy dynamic programming all the way to hard, right? You want to cover as many concepts as you can, and then gradually build on your understanding. Okay. Another resource I recommend is LeetCode contests. Every Saturday at 9 p.m. there's a LeetCode contest where you will be given 4 different problems to solve in an hour and a half, and you have like a contest rating, and you're competing against other users. But the main benefit of the LeetCode contest is helping you solve problems with a time limit, right? Because in an interview, you're not going to be given unlimited time, right? You usually maybe like 30, 45 minutes to solve a problem. So the LeetCode contests help you assess how you're doing on time, and it gets you comfortable solving problems in a time constraint. So I love the LeetCode contest. I've done quite a few. I think they're super helpful and underutilized, so I definitely recommend checking those out. Again, these are every week on Saturdays at 9 p.m. and every other week, so bi-weekly, they will have an additional contest 9 a.m. on Saturdays as well. Consistency is key, right? I have a tendency for my midterms and finals to kind of cram everything at the very end. right? Lose a night's sleep just going over all the slides and homeworks and everything in a test just right before the test is about to happen so that I can, do my best. But, and I assume a lot of you do that as well. But we know that the correct way to do it is to study diligently all throughout the semester, even though that can be hard. And the same is true for LeetCode, problem solving, this kind of stuff, right? You are not going to be able to, just a week before your interview, cram every single topic, every single concept, do 50 problems all in a row, and then on interview day be able to perform. This kind of stuff is something that you need to do consistently. I would encourage like daily, right? So even if it's a super easy problem, just solve at least one problem a day so you are doing it consistently. And you're really just building up your knowledge over time. If you have an interview in the next week, then, that's a little harder. Maybe you should cram a bit, but this is going to be helpful for the long term. I would just really encourage you, be consistent with your study, with your practice, with your problem solving, and you're going to see great results. All right. Fundamental data structures and techniques. These are covered in the lists that I provided earlier, but if you are not if you're not shooting for like some super high job where they're going to ask you some whack questions, these are sort of like the fundamental things you want to do. So to avoid studying topics that are not going to be useful for you, I would recommend studying these. And even this might be maybe overkill depending on how high you're shooting. But definitely arrays, that should be a given. Hash maps are probably like the most important data structure to know in an interview. Strings, linked lists, trees, graphs, and then some questions will use a heap, and those are important to kind of know what those are good for. And then the fundamental techniques, 2-pointers, sliding window, DFS, BFS, or graph traversal, recursion, and backtracking. I think I'll send out these slides afterwards in the ACM Discord, just so that you can refer back to them. If you're like, oh, what topic should I practice next? You can take a look at this, and it's like, okay, well, I don't know what a heap is, so let me figure that out, right? But these topics are pretty much what you want to be covering. All right. So a roadmap for when you're first given the question, the problem, how should you approach that, right? It's no good to just, even if you're like the best programmer in the world and you can blitz out a solution, if you just like sit in silence and code and then you're done and you say, I'm done, then that's not good, right? You didn't communicate. You have to communicate to your interviewer. It's not enough just to solve the problem. You need to explain what's going on. So here's sort of a roadmap. When you're first given the problem, usually there's going to be some specifics missing, right? So you want to clarify the constraints and the edge cases. If you're given some problem and you don't know what the input size is, or what the maximum input could be, then you might write like a brute force solution without ever realizing that you need to go further, right? So you want to clarify your constraints. If you're given an array of integers, how big could this array possibly be? If the interviewer says up to 100,000 elements, then you know that your solution needs to be of like linear time complexity or n log n or something less than that, right? N squared is not going to cut it. It needs to be sort of optimized. And edge cases. Can we possibly be given an empty list? Will that work? Are there zeros in this array? Are there negative numbers? Things that could potentially trip you up. And it just shows your interviewer that, this guy is thinking ahead. He wants to be able to solve the problem as best as possible. He knows what he's doing, right? After you're done with that, it's helpful to write a brute force solution that will work on smaller input, just to, well, I mean, there are a variety of reasons that this is good. One, if you can't figure out the optimized solution, sometimes just a brute force that works, even if it's inefficient, will be enough, right? It's better a brute force than nothing. Plus, as you're writing the brute force, it'll give your brain more time to subconsciously think about what a better approach could be. And so as you're writing the brute force, or as you've finished, oftentimes you will have an idea about what you can do to write the correct solution, right? So I recommend writing some sort of brute force at the beginning. After you're done with the brute force, you need to discuss possible optimizations. Again, keeping a conversation with the interviewer, right? You can't just think and say nothing. That's not good. And it's hard to talk while coding, but it's a skill that you're going to have to try and practice. So you can do like a mock interview with a friend, or just practice talking aloud as you solve the problems. But after you've written the brute force solution, talk to your interviewer. Say, okay, this is a brute force, but I think there's something better we could do here, like use a hash map to keep track of, you know, values that are showing up a lot, or the last position of something. Or you might say, well, you know, actually, I think if we sorted this list first before doing anything, then we could reduce the time complexity down to n log n, these kinds of things. If you have no idea what a possible optimization could be, then you'll see what to do later on. But after you have hopefully figured out what you need to do, then you write the optimized solution, again communicating with your interviewer as you go about what you're doing, why you're doing it. Yeah. Then after all that's done, you'll want to show your interviewer that the problem works by testing it on some small inputs, right? So you can write sample cases, run your function typically on the code. If you're not given like a working code editor, you can dry run it. So just kind of like walk through it step by step, like verbally, to show like, okay, yes, so we get this first number, which does this, stores it in here, and then, you know, work through the example and show how your solution is correct. But the big overall theme is that you need to communicate, which is tough as computer science majors. Talking to people can be scary, and it is kind of unnatural to do. We're very used to sort of coding in silence. But I mean, it's something that you gotta get over, basically. And it's not something that you'll just be able to do naturally. So practice. Okay. If you're stuck, if you don't know what to do, you have some options. Verbalize why you're stuck, what you're stuck on. So if you have some sort of like basis for the problem, but there's something that you're not quite getting, verbalize that, right? You can say, well, I have this hash map, and I know what I want to kind of store as the keys, but I'm having some difficulty figuring out what the values could be, because we want X and Y, whatever you know about the problem, try and verbalize what's going on, which is actually a technique that many programmers use to just debug by themselves. If anyone's familiar with the concept of rubber duck debugging, you've got like a rubber duck on your desk, and when you're stuck on a problem, you can like talk to the duck about what's going wrong, why it isn't working, and then you know, oftentimes magically you'll figure out what's going wrong just by verbalizing it. If you need to just pause and think, you have to ask first, right? You can't just be talking to your interviewer and then all of a sudden just go blank, right? So something along the lines of, you know, do you mind if I like pause and think for a second? I need to think about this. Goes a long way, just asking, right? You need to constantly be in communication with your interviewer, and when you're not, you need to make it clear that you're pausing to think. Work through a small example. If you have a small input size for your problem, just like an example case, work through it again, right? Okay, this is the input we have. This is what we want. Work through what the, not necessarily the solution, because you might not have it, but work through, say for example, if it's like the duplicated values in an array problem, right? You just work through the small example, say, okay, we've got our first number, that's fine. Second number, maybe that's the duplicate, and we need to store that somehow, right? And just, that's a simple example, so maybe not super helpful, but working through what exactly needs to happen is, I mean, it really will oftentimes just like help you. And then ask for a hint. You can do that if you do it correctly, right? You can't just like be working on it and go, can I get a hint? Right? If you have some sort of thing already, like you might say, well, I think we might be able to solve this using like sorting or hash maps. Do you have a way that you would like me to proceed with this? Is there, like, what do you think the best path forward would be here, right? Something that is, it just kind of feels right. Instead of asking for a hint, you kind of give some information about the problem, where you're stuck, and ask them for guidance, right? It is, you should think of it as like solving the problem with your interviewer instead of just, I need to solve this or I don't get the job and I gotta do it as fast as I can, right? It's like a problem solving session. You have your interviewer, you have you, and you're trying to solve it together. Obviously, they're not gonna write any code, but they're not just like a blank wall, right? You can ask them. Obviously, you can't ask them for the full solution, but oftentimes you can just ask for a hint, and that might be all you need. Okay, what time is it? It is 4:21. Okay, let's work through an example. So, I'll open my ID. Oh, do this. Let's say your interviewer asks you, if you are given an input list of numbers, I want you to find two numbers that add up to some given target, right? And you've probably heard this question before. If you've done leak code, this is twosum. So you would probably have some function, right? Let's call it two numbers. So given some input list of numbers and a target, and your interviewer says, find me two numbers that will add up to the target. And so you need to clarify some things, right? Okay, so you would ask, are these numbers like floating point numbers? Are they decimals? Are they integers? And your interviewer, they'll know. They can say, yes, it's going to be integers. And you say, okay, do you want the numbers themselves or the indices of where the numbers are located? Again, clarifying. They'll say the indices, maybe. Okay, so now we know that it's going to be integers, and we know that they want the indices of the numbers. And you just keep asking more clarifying questions. Are we guaranteed to have a solution? Like, is there a guaranteed correct answer in this list, or should we do something if no solution exists? And so in this case, maybe we know that there will always be a solution. And you can write this stuff down in like a comment, right? Integer array, return indices of two numbers that sum to target, solution guaranteed. Okay. And once you've clarified enough that you think you can start working on the problem, then you start with your brute force, right? So you say, okay, I think I know what to do. Let me write a brute force solution just to get a working code, and then we can optimize from there. So your interviewer says, okay. Hopefully they say okay. Obviously, you're going to have to go with the flow. If something doesn't go according to plan, that's part of it. But hopefully they say, all right, and you go, all right. So, oh, here's another clarifying question, that if you run into an issue, you can ask a clarifying question as it happens. So I'll actually do that. So let's see, what's a brute force? Well, we need two numbers that add up to a target. Well, we can just run through every pair of two numbers, every possibility. So hopefully you all know how to write a for loop. If not, then you might be in the wrong lecture here. Do this in your language of choice. Python is the best language for interviews because it's very simple. Your your interviewer, if they're not familiar with Python, can usually follow along pretty well. And it comes with a lot of built-in sort of modules to help. Okay. So you say, let me write a nested for loop so I can run through every pair of indices and then just check if they add up to our target. You say for I, in range, length of nums. For j, in range, length of nums. If nums at I plus nums at j is equal to our target, return I, j. Maybe this is the format, right? They want it in an array. Maybe they want it in like a tuple. It's fine as well, but you'll have some format, right? And you could run this. And there's a slight thing here that you might not notice, and if this happens, if it wasn't specified before, your interviewer will probably bring it up, but they might say something like, okay, you can't use the same index twice, right? And an example where this might come up is if you have like 1, 2, 3, 3, 4, and your target is 6. Then your code here, or sorry, wait, 1, 2, 3, 4. Then your code here might return, well, in this case it wouldn't. In this case it would. So this might be invalid, 1, 1, right? Because, well, 3 plus 3 does equal 6. But there might be some constraint that you can't use an index twice. But there might not be. It's good to clarify again. So let's say we made this mistake, and the interviewer says, you can't use the same index twice, right? Okay. Well, there are a few things you could do. You could say, if I is equal to j, continue, right? That would work. You can maybe impress them a bit by saying, starting j at I plus 1 and going to the length of nums. But eventually, you'll have your brute force, right? And then you think about how to optimize. And you could say something like, well, And hopefully at this point you've figured out what you need to do. If you don't know what to do, then you can refer back to the things I said before. But if you just straight up have no idea, then that's, I mean, there's not much to do there. But let's hopefully say that you know what you need to do now, and so you verbalize that to your interviewer, right? And you say, well, okay, so if we have a given target, we know if we have some number, we can compute what number we need to add to it to get to our target, right? If our target is 7, and we're at some 3, then we know that we need a 4 to get to our target, right? And only a 4. You can't do it with some other number. We're only given 2 numbers. And so what we can do is we can store the positions of the numbers that we visited in a hash map. And that way, as we iterate through our list, if we hit some number and the complement is in the hash map, right? If we run into a 3 and we've seen a 4 already, then we know that they add up to the target, and we can return the index where we're at and the stored index of where the complement number is. So let me code that up really quick. You say for I in range nums, right? Loop through. You go, okay, well, we want to store the indices of these things. So let's make a hash map. Call it last index is equal to some map. And okay, so for I in range nums, well, our num is nums at I, and we want to store where it is in our map. Okay, and what else do we need to do? Well, we need to figure out, given some number, what is our complement number, right? Well, our complement is going to be target minus num. And this will need to be on this line. Right? Okay, so if our target is 7 and our num is 3, then complement is equal to 7 minus 3, which is 4. Perfect. And then we need to see if we've run into a 4 before. So if complement is in last index, return last index at the complement and our I, which is where we are right now. Just as an aside for this particular question, you might run into an issue if you do this, right? So if you store it before you check, then you'll run into this issue again, the 1, 3, 2, 4, right? Because if you store it and say that you've seen a 3, then that 3 that you're currently at, when you check to see, if you've run into the complement before, sorry, and this is assuming a target of 6, then you will have already stored it, and then you'll say, oh, no, I've seen this number before, until you return 1, 1, which is no good. So you'll need to store this afterwards. Okay. So then after you've written your optimized solution, it's good to run through some test examples and say, okay, well, let's see if this is working correctly. Say our input is 2468, and our target is let's do 10. Excuse me. And then we'll keep like a comment of our map. Okay. Okay, so for I in range nums, that's going to start at 0. Num is equal to nums I. All right, num is 2, and our complement is target minus num. So 10 minus 2 is 8. So our num is 2, and our complement is 8. If complement is in last index, well, it's not, so we skip that. Otherwise, last index of num is equal to I, which means that the num we're at is 2, and the index we're at is 0. Okay. Then we hit 4. So our I is 1, our num is 4, our complement is 10 minus 4, which is 6. Is the complement in our map? No, it's not. So we store the index of the number we're at. Okay, so 4 is at index 1. All right. So now our I is at index 2. Our num is 6. Our complement is our target minus our num, which is 10 minus 6. So our complement is 4. Is the complement in our last index map? Yes, it is. So we return the index of the complement in our map. So we return 1 and the index that we're currently at, which is 2. Okay, cool. That seems like it works. And then maybe you run through a second example where you avoid that bug before. Right, 3, 2, 4. And I won't run through the whole thing, but you can basically say, okay, well, once we reach this point, since we are storing it after we're doing our check, then we don't run into that issue. And so at this point, your interviewer will say, yes, that looks good to me. That's an awesome solution. And then you get the job and you get hired and you're happy. Or they give you another problem and then you have to do the whole thing over again. They say, you're too good at this, let me give you a real tough one. But hopefully that doesn't happen. Okay. We can run through another problem, or I could let me take questions first. Does anybody have any questions? Yes. They let you find out. Okay, so if you're able to write code and like run it through test cases, if it's like a hacker rank or code signal, that sort of thing, then because you said let you find out, right? Which could imply that there is like test data for your code to be run on. If you're doing like a hacker rank or code signal, then everything you'll need should be there, right? So it'll say at the bottom like what your maximum input size could be. If there's nothing like that and it's just like a Google Doc or something that you're writing code into, then you just kind of have to make assumptions, right? And verbalize these assumptions. If they are wrong and your interviewer cares, then they'll say something about it, right? So you say, okay, well, I'm assuming that we won't be given an empty list here, right? And so that could go to your interviewer says, okay. Or they say, no, you need to account for an empty list, right? So if they're being kind of weird and not answering the questions that you're asking for clarification, then you want to let them know what it is you're assuming. If they don't say anything after you've given them an assumption, and then once you're done they say, no, that's wrong, you didn't account for this, then first of all, it's a pretty bad interviewer. You'll have to fix it, in which case, I mean, what more could you have done, right? If you're confident on the problem, you could try to account for the worst case, like assume negative numbers, assume empty lists. If you're not confident and they won't give you clarifications, then you could assume the best and then write a working solution for things that aren't so tricky. But essentially, verbalize your assumptions and yeah. Does that help? Awesome. Yes. Um, I'd say it's more likely to just be like a Google Doc sort of thing. You can get lucky though. The online assessments are code signals or hacker ranks. If you've done a online assessment, then that's pretty much what you get every time, right? But in person you can get lucky, but more often it's like a Word document or something, which is annoying. Any other questions? Yes. Sure. Um, well, I mean, the best way to practice is kind of unanswerable, but a common good way to practice is with like a mock interview, right? So you might come to me and say, Jonathan, I need your help. I've got this interview coming up, and I don't know how to talk to people while I code. And so you do like a pretend interview, right? It's a low stakes environment. You can talk to me. I'm not going to make fun of you. I'll give you like a problem to solve, and you can work through it and practice talking while you code, right? There's no pressure. Another good way to practice is just talking to yourself, talking out loud as you solve a problem. The way I practiced was running the the club here to work through these problems. So I have to talk while I explain the solution. So I kind of cheated that one a bit. So you could start a club, but I'd say the best sort of most accessible method is to practice just talking out loud to yourself as you code, and hope that people around you don't judge you too harshly, or you can do it by yourself. Mm-hmm. Find a whiteboard. I don't. Yeah. Right. Hmm. I mean, the simplest way to practice that, I guess, would be to go to LeetCode or some site, find a problem, and try solving it on a whiteboard. Go through your solution, justify it in your mind, and then once you're done, you can like copy it back over and see if it works. Um, I mean, I think that sounds like a perfectly fine way of going about it. Um, it might be best to try a variety of different practice methods, right? Try solving problems like on your IDE where you can solve things. Try solving problems where you can't just write in a code editor, like on a Word or Google Docs or something. Try problems where you're doing that speaking out loud. Try it on a whiteboard, silent. Try it on a whiteboard, speaking out loud. Eventually, hopefully, with enough practice, you gain practice solving problems in lots of different types of uncomfortable scenarios, right? Which is what an interview is. You have to solve this problem in an uncomfortable scenario. And each company is going to be a bit different. So if you have experience solving problems on a whiteboard, talking aloud, all these different things, right? Then the goal is that you should be comfortable enough to do well. Yes. My mindset. Mm. Right. Um, hopefully, hopefully not everything is writing on this interview, and you can go into it as calm as possible. Um, obvious, obviously, if you're like one interview away from unemployment, then that's not great. Um, but you want to be calm and collected, right? Uh, obviously, there's going to be nerves, and it's not like totally controllable. But the mindset um, that I would recommend is um, I want to be calm. I want to. I mean, I guess just I want to be calm. I want to communicate to my interviewer successfully. I want to solve this problem collaboratively. Um, if you're not thinking about the job as much, then that's helpful. Um, and one thing that I like to do is, think of it as practice, right? You get like a free mock interview, even though it's an actual interview. You have practice for the next time, right? Now you have practice talking with an actual interviewer, solving a problem that you've never seen before under time constraints. How great of practice is that? That's awesome, right? So then in your next interview, you're even more prepared. So you can, again, if this is kind of like your last chance, then that not so much. And I don't mean to like bring be a doomsayer or anything like that. I don't think that's a real word, but uh, if you think of it as like practice, then that I think that's helpful. Cool. Any other questions? No? Okay. Did everybody get checked in? You didn't? Oh, right. Let me pull that up again. Here we go. Yes. Hey, we'll get there. We'll get that's after this. I got another slide. I got another slide. Okay. Last slide. Okay. So again, my name is Jonathan DeConing. ACM has a sub-organization called ICPC, um, and it covers essentially the whole problem-solving side of that. Right? In this 1 hour, I couldn't explain, how do I reverse a linked list? How do graphs work? How do you traverse a graph? All that sort of stuff. Right? I didn't have time enough for that. That's what we do at ICPC. We go over all these fundamental techniques, data structures, algorithms, that kind of stuff. We meet weekly. This is the QR code for the Discord. I mean, I can even pull up, like, we go through a lot of problems, right? We have like a problem a day that you can work on and ask other people for guidance, ask me, and then you can show up on Fridays at 3 p.m., go over the problems, go over what got you tripped up. I will do some sort of lesson on a specific data structure or something, like sliding window technique. It's a great resource, and if you're having trouble solving some leak codes, I would definitely recommend that you show up, see if you like it. I think it's awesome, so you can take my word for it. But if you're interested in joining, then that is the QR code. And it's not like a huge commitment. I'm not going to force you to show up every day. I mean, every week. Also, we have donuts. Every meeting, we have donuts. So if you like donuts, you can get some. I think that's it. We went a bit early. like 10 minutes. Yeah, you get 10 minutes of your life back.
And if y'all are interested in actually getting those interviews, Ready Creators works on semester-long projects. I'm also plugging them. Go check out the Discord. It's in the ACM regular Discord. But yeah, have a nice day.